This video will cover create, read, update and delete functionality using Firestore in Flutter. Hey guys, this is Dane from FullStacks, and in today's video we'll be covering how to do the CRUD operations using Firestore and Firebase. So if you haven't been following along, this is a series of Firebase and Flutter where I'll be using Firebase as the backend to build a mobile application. For this tutorial, I have updated the code from the previous tutorial to make it easier to focus on specifically the create, update and read functionality. Head over to fullstacks.com and open up the CRUD tutorial. Then under the banner image, there's a download code button which you can press and you'll get the code that I'll be using in this tutorial. Once you downloaded the code, you can open it up in Visual Studio Code and get all the packages. The first thing we'll do is add the create a post functionality. You can go over to your Firebase console and open up your Firebase project. Then on the left side, click on the database icon. When it loads, we'll add a new collection as a root collection and call it posts. We'll create an auto ID and then give it a field called title and a value called first item. Then you can go back to the code and open up the Firestore service. We'll start by adding a collection reference to the posts collection. So you can duplicate the code for the user collection reference and change the name to posts collection reference, as well as the collection name to posts. Then in the bottom of the class, we will add a new function that returns a feature called add post that takes in a post object. Since I'm not focused on the refactoring in this tutorial, we will copy the code for the try catch that handles the exceptions and we will paste that in the add post function. We can then delete the body of the try statement. To add a post to a Firebase collection, all you have to do is call the add function on the collection reference and then pass in the map data. So if you didn't know, the documents on Firebase are actually just stored as JSON objects. So for the toMap function, all we do is return a map with a key of type string and a dynamic value. Then we can go to the create post view model where we'll add the business logic. We'll start by getting the Firestore service from our locator, which is what we'll use to create the post on the Firestore database. Then we'll get our dialog service, which we'll use to show a message to the user after we've added the post or if the post failed to add. And the last service we'll add is the navigation service, which we'll use to navigate away from this view after we've added the post or if the post failed to add. Then to handle the actual business logic, we'll create a new function that returns a type feature called add post that takes a required string value called title. The first thing we'll do in this function is set the busy indicator to true. Then we'll create a new variable called result, which will store the result returned from the add post function, which takes in a post where we can set the title equal to the title passed in from the add post function. We'll also set the user ID equal to the current user's ID. And then to close off the async functionality, we'll set the busy back to false. So before we add the rest of the code, we want to make sure that the current user is available within this class. In the previous tutorial, we added the current user to our authentication service, and now it's time to make use of that. You can open up the base model class where we will fetch the authentication service from the locator. Then we'll create a new get property called current user, and this property will return the current user from the authentication service. Then the next thing we'll do is we'll check if the result is a string. If it is a string, we know that it's an error. So what we'll do is we'll show a dialog using the dialog service. The title we'll set to could not create post. And for the description, we'll just show the result. And if the result is not a string, we know that it was successful. And if the post is successful, just for our sanity on our side, we also want to show a dialog to indicate to the user that the post was successfully posted. We'll set the title of this dialog to post successfully added. And for the description, we'll say your post has been created. And then the last thing to do in this function is to navigate back to the home view. Then to link all of this functionality together, you can open up the create post view, and at the place where there's a to do, you can add a check to see if the model is busy or not. And if the model is not busy, we will call the add post function on the model. We'll pass in the text from the title controller as the title of the post. If you run the code now and you log in with your username or create a new one if you haven't used one before, you'll see some fake data that I added just to show that the post item UI has been built. And then if you click on the fab in the home view, you'll go to the create post view where you can type in a title. Once you've typed in a title, click on the floating action button on that view, and you'll see in your database on the console that a new post is created with a title that you typed in. Once you press OK, it should navigate back to the home view. So currently it's not showing any of the posts, which will be the next topic that we tackle, which is reading the posts from the Firebase database. So the main functionality for Firebase is the real-time database functionality. And when I started using Firebase, I wasn't very comfortable using the streams and the real-time functionality. And so I also learned how to do the once-off requests, meaning it will be handled like a traditional API where you do one single call and you'll get your results back, and then you choose to do another call if you need the results again. And because I've seen a lot of confusion around the real-time database implementations and how to use it, I'll start off by doing the once-off requests, and then I'll add the real-time functionality onto it afterwards, and you can choose for yourself which one you want to use. Head over to the Firestore service and create a new function called getPostsOnceOff. Then copy the code from the add post function and remove the try body. We will start by creating a new variable called posts document snapshot. And in this variable, we'll store the results from the get documents function call on the post collection reference. This will return to us a query snapshot. This object contains a list of documents which we can check if it is empty or not. If it is not empty, we want to change these documents into actual post objects and return that to the calling function. So for the return statement, we will index into the documents, and on that documents list, we will call map. And for each of the snapshots that we map, we will create a new post and use the FromMap static function. We'll pass in the data. And then just for safety, to make sure that we don't get any items that has a null title, we will check where the mapped item has a title that is not equal to null. And the final call will be a toList to make sure that we get a list of posts out of this function call. We can quickly look at the FromMap function so you know what's in there. We simply just get a map from the snapshot and then we index into it using the same properties that we use when we call the toMap function. You can open up the home view model where we add the actual functionality to get the posts and display that to the user. We'll start by importing the Firestore service using the locator. We'll also import the dialog service, which we'll use to show a message if we can't get the posts for the user. Then we'll create the variables that will store the actual posts that we'll fetch. We'll create a variable called posts that is private and will be a type list of type posts. We'll also create a public getter called posts that will return our private posts variable. Then we'll create a new function called fetch posts. It will return a future and we'll mark it as a sync. The first thing we'll do is set the model to busy. Then we'll create a new variable called post results, which will call the get posts once-off function on the Firestore service. And after that call, we'll set the busy value back to false. So just as a quick note, there's a lot of code that I'm duplicating, and that is to make sure that I'm showing the most basic way of doing this, and then based on your own refactor patterns and principles that you like to use, you can do the refactors to share the error handling as well as things like this where we check the type and then show a dialog if the results is not matching the exact type. These functions can be turned into a generic static helper function that we can use throughout the application so that we don't duplicate the code for this specific functionality every time. Once we get the post results, we'll check if it is of type list of type posts, and if it is, we'll set the private posts variable equal to the post results, and then we'll call the notify listener so that we can rebuild our view. If the post results is not a type of list posts, we'll call show dialog on the dialog service and we'll give it a title posts update failed. For the description of this dialog, we will pass in the post results directly since that will contain our error message. Then you can open up the home view and you can remove the child that's currently being supplied to the expanded widget at the bottom of the view. We'll start off by adding our conditional and we'll check if the posts is not equal to null. And if the post is not equal to null, we will return a list view builder with the item count set equal to the length of the posts on the view model. For the item builder, we will provide a function that takes in our build context and the index. The post item takes a post and we'll get that post from the posts list in the view model using the index supplied by the item builder. And if the model.posts is equal to null, we want to show a circular progress indicator in the center of the view and we'll give it a value color using the primary color of the theme. Just to check that everything works, we can run this before calling the fetch posts function and you should see the circular progress indicator spinning while we are waiting for the code to return. Head to the top of the build function and under the view model, we'll supply an onModelReady callback. And for that callback, we will simply call fetch posts on the model. If we restart the app using the restart button, you'll see that as soon as we get in, there'll be a loading indicator and then the list of posts will load. That is all you need for the once off requests. If you have a query or a document or a collection reference, you can simply call get on that object and you will make a once off request to get the information stored in that document or in that collection. The downfall with this method is that it is not real time, meaning when I add something into the database directly or if another user adds it in, the current user won't see it because it won't be updating in the real time. The same goes for simply just adding a post. Once you've added it and you navigate back to the home view, there won't be any post that has been updated. We can fix the refresh functionality for the adding of a post. You can open up the home view model and for the navigate to create view function, we'll change it into a future and mark it as a sync. We'll then await on the navigate to call, and after that has been completed, we'll call the fetch post functionality. The way that this works is once we navigate back from the create post view, so once it has closed, it will continue on to the next line, which is the fetch posts, which will then refresh our data and then show it on the home view. The preferred functionality for me is the way that I'll be showing you now, which makes use of the real-time data updates and streams instead of futures to go fetch the data. The way the real-time mindset should work for you is when you request the results, you are telling Firebase that you want the current results, and if anything changes, please call this exact same function again, and then I'll handle that updates as it comes through. The way that that looks in code is that you ask for the document snapshots, which gives you a stream, and then you give it a function to call whenever there's new data available for that specific collection or query that you're listening to. Then for us, we will internally have another stream controller which provides us with a list of posts. Whenever our handler function is called, all we'll do is serialize all the snapshot documents into a list of posts and then put it onto our stream controller, which we'll then have a link to in the view model, and that will then refresh our posts and then show the new data as it comes through. So number one, we listen to the snapshots in the Firestore service. The snapshots will then be serialized into a list of posts. That list of posts we'll put onto a stream controller, which we'll listen to in the view model, and then we'll show that posts in the view model. It might be more confusing. I do understand that, which is why I showed you the once off functionality, and if you get more comfortable with streams, you can then start using the real-time functionality. And to make you a bit more comfortable, I do have a streams video which I'll link right here at the top right now, and it shows you how to create your own stream, which might make you feel a bit more at ease with the idea of having streams and how it works. So go to the top of the Firestore service where we'll create a new stream controller, and the stream controller will be emitting list of posts. We'll call the stream controller a posts controller, and we'll simply initialize a new stream controller at the construction of the Firestore service, and we'll use the broadcast constructor to make sure we can subscribe multiple times to the same posts controller. Then we'll add a function that returns a stream called listen to posts real time. The first thing we'll do is we'll register the handler with the Firestore snapshot stream that will handle the data that comes through whenever there's an update to the Firestore database. The way we do this is by simply getting the post collection reference, calling snapshots, and then calling listen on that stream that is returned by the snapshots function. We'll supply an anonymous function that takes in a parameter called post snapshot. And in this part might make it a bit easier to understand. We'll copy the exact code that we use to deserialize the post document snapshots in the once of request and paste that into our handler function. The reason for that is because it's the exact same thing. The only difference at this point is that we'll get continuous calls of this anonymous function that we can then do with whatever we want to. And what we'll do is store it in a posts variable and then put that list of posts onto the post controller using the add function on the controller. And then the last thing to do for this function is to return the stream that's underlying that posts controller. So whenever there's an update in this specific function or collection, it will add the data onto this post controller. So if you ever want the updates from that anywhere, all you have to do is listen to the stream that you get back from calling that function in the first place. So open up the home view model and then remove the fetch posts function as well as the call from the navigate to create view. Then we'll create a new function that will return a void called listen to posts. The first thing as usual is we will call the set busy and set that to true. Then we'll call the listen to posts realtime function on the Firestore service and we'll register an anonymous function with the listen function on that stream. The first thing we'll do is cast the posts data to a list of posts called updated posts. And then we'll check if the updated post is not equal to null and if the length of that post is bigger than 0. And if both of those conditions are satisfied, we will set the posts equal to the updated posts. And then we'll call the notify listeners function. Whenever that is done, we will set the busy back to false. Then you can open up the home view and change the onModelReady call from fetch post to listen to posts. And that's all that we had to do to change our home view to listen to the real-time updates. You can run the code now and then open up your Firebase console project. When the project is open, you can go ahead and add a new post entry. All you do is click on the add document value and generate an auto ID, then put a field called title and then add a value in there. As you save, you'll see that the value on the home view is added into the list and it's shown immediately. The same thing goes for when you delete a document. If you click on a document in the DB and you delete it, you'll see the home view update immediately. Now this functionality is not required for every mobile app, so I understand if you don't want to use it, but it does take some functionalities that we had to build in the past out of the picture. The one major thing is the traditional pattern of the pull to refresh, where you have to request the new information because your view might not be updated based on changes that a user has made in a different app, in a different instance, or on the database in the backend. So it's all up to you which one you want to use. I usually use the real-time database because I've now gotten used to the functionality and the structure of the architecture. It takes out all of those additional refresh calls and checking if the data is available. Simply by getting all the data on the startup and having the offline mode as well makes my life a lot easier. Next up is the delete functionality, and to perform this functionality we will require the document ID, as we'll be using that to delete the document from the collection. Open up the posts model and add a new final string called document ID and pass it in through the constructor. Then in the FromMap call we will add a new parameter called document ID, which we'll set in the post model when we return the constructed object. Then open up the Firestore service, and everywhere we use the FromMap call on the post model, we will now pass in snapshot.documentID. Then go to the bottom of the Firestore service and we'll add another function called delete post that returns a future and takes in a document ID. What we'll do in this function is we'll index into the document using the document ID passed in, and on that document we will call the delete function and await on that operation. Then to add this functionality into our home view model, we'll create a new function above the navigate to create view function. It will return a future and it will be called delete post. It will take in an index from the home view. For this functionality, I want to first ask the user if they really do want to delete this post. If they confirm that they do, then we'll call the Firebase function to delete the post. So we'll start off by creating a variable called dialog response, which will hold the result from the show confirmation dialog call on the dialog service. The title I'll set to "Are you sure?" and the description will be "Do you really want to delete the post?" For the confirmation title, I will put it to yes, and for the cancel title, I will set that to no. Then once we have passed that call, I will check the dialog response and check the confirmed boolean. Then I will set the busy indicator to true and then call the delete post function on the Firestore service, passing in the post's document ID using the index passed into the function. And after that, I will set the busy back to false. For this implementation, because I didn't want to give the post item its own view model, because there's still some people struggling with the term callback function, I will supply a callback function instead, which will call back to the home view, where we will call the delete on the home view model. So in the post item file, add a new final function called onDeleteItem and pass it in through the constructor. Then in the onPressed function for the close icon, we will check if the onDeleteItem is not equal to null, and if it's not equal to null, we will execute the function that we pass in. Now back in the home view where we create the post item, we can now pass in the onDeleteItem function, which will be an anonymous function that calls delete post and passes in the index of the current post item. If you run the code and you open up the console side by side, once you delete a post on the home view, you'll see that the console deletes the same post as well. You can click on it, you'll get the confirmation dialog, and it will delete the post when you say yes. The last thing we want to tackle for this video is to update a post. The way we'll do that is if a post is tapped on the list view, we'll navigate to the create post view, but we'll fill in the title that the post has that we tapped on. Then when you press the add button, it will check if the post is being edited or if it's a new post, and if it's being edited, we will simply call the update post function on the Firestore service. The first thing we'll do to implement that functionality is go to the Firestore service and add a new function that returns a future that takes in a post object called update post. Then we can go to the get posts once off function and copy the try catch statement functionality and clean out the body of the try block. And inside of the try block, we will now get the post collection reference. We will get the document using the document ID from the post passed in, and then we'll call update data on that document and pass in the toMap function from the post. Then you can open up the home view, and now we have to add a gesture detector to the post item so that we can navigate to the post item once we click on that item. For the onTap function of that gesture detector, we will call the edit post function on the view model that we are about to create. You can generate or create the function in the view model and then make sure that it returns a void. So what we'll do in this function is call the navigate to function on the navigation service and pass it create post view route. The main difference between this and the top function is that we'll also pass an argument which will take in the actual post using the index passed in from the edit post to index into the posts list. Then you can open up the router file where we'll update the case for the create post view route to now cast the arguments into a post. We will create a new variable in that case called post to edit, and we'll set it equal to the arguments from the settings cast to a post object. Then we'll pass into the create post view a new variable called editing post, and we'll pass in the post to edit. If you open up the create post view, we will now create a final variable of type post called editing post. We'll pass that in through the constructor. The next thing to do is to make sure that the values reflect the post being passed in, if there is any. So we'll supply the onModelReady function callback, and then we'll set the text of the title controller equal to the title from the editing post if it is not equal to null. If it is null, we'll set it to an empty string. Then we'll set the editing post on the model by calling a function called setEditingPost and passing in the editing post. We'll create the function on the view model, make sure it returns a void and it takes in a type post. You can go to the top of this view model where we'll store a private variable called editing post. And in the function we just created called setEditingPost, we simply set the post equal to the editing post variable. We'll then also create a private getter property called editing, which will check if the editing post is not equal to null. Then to start with the business logic, we'll move the creation of the result variable onto its own line of code. Then we'll check if the post is currently being edited by using the editing property. If it is not being edited, we will simply call the addPost function on the Firestore service and set the result of that call equal to our result variable. If the post is edited, we will call the updatePost function on the Firestore service, and we'll construct a new post where the title will be equal to the new title passed in, and the rest of the properties for the post will be fetched from the editing post model. The user ID will be set equal to the user ID of the editing post passed in, and the same will go for the document ID. If you run the code now, when you get to the home view, if you tap on one of the list items, you'll get to the create post view with the title already filled in. If you update that title and press the add button again, you should see the same dialog, and once you are back, you'll see that the post has been edited. I've been saying the word edited and editing a lot in the last few minutes, so my mouth is pretty dry. That's about it for the CRUD operations in Firestore. As always, thank you guys for watching. Thank you for subscribing, sharing my content and talking about it. I really appreciate it. I think the more feedback and functionality we can get and the more eyes we get on our architecture, the better we'll be able to perform our job when building applications for clients or for the companies that we work at. Thanks for watching. I'll see you guys next week.